Okay, so let's give this title Fractions and Decimals. There is a more efficient way to represent fractions and look at fractions as we move from the leftmost basic intuitive side of understanding. As we move to the right, there are properties and ways to do things that are more efficient, more effective. Using decimal numbers as representations for fractions and mixed numbers is one of those things. So if I just do this by example, well, not first, let me just set this up. So if we just look at integers, we have our hundreds place, hundreds and tens and ones, and then we can go smaller, still based on 10, and have tenths, and then we separate that by our decimal point, and hundredths, and so on, in either direction. Now it's still based on powers of 10. They can just get smaller and smaller as well, past the whole number parts on the left and the right of the decimal point. So let's see what we get with some exercises. One way to, well, the main way for us to convert a fraction to its corresponding decimal representation is by using long division again. So we have these three. So let's have a look. So that's exercise 1412, number 1. We have 5/20ths is what? So we want to look, we're not changing the quantity that it represents, we're changing the representation. So this we saw with our division last time, that the top, well, this is really sort of equivalent to 5 divided by 20. That in certain basic division instructions where I can't even fit the group size in, I just get my fraction that corresponds exactly to the division, saying that these are actually equivalent when I interpret them. So that means that the 5 is going to go inside my house, the 20 is going to go outside my house. Now, we haven't done long division that much with multi-digit numbers as the divisors, but 20 is not a bad one. So we won't go crazy with these. So we start by saying 20 goes into 5 0 times. Then I still have something left. I now need to keep going until I don't have a remainder anymore. So I'm going to have my decimal place and then just shift my view, just like we shifted our view from thousands, hundreds, tens, ones, and so on. I'm just going to keep shifting it to the right. And when I do that, the method doesn't change. It says, look at this relative to that position, which then makes it 50, because this is 50 tenths. 20 goes into 50 2 times, and I have to keep everything in line there, because it's really 20 goes into 50 tenths, 2 tenths of a time, I suppose. So 2 times 20 relative to the position is 40. Now it might bother people to see the decimal point there. If it bothers little Timmy, leave it out for a little bit. We know it's there. As long as it's there in the answer, separating those positions, it's okay. So do whatever makes Timmy comfortable, because this division method allows me to sort of look locally and forget where I am in the larger scheme of things. So it's very convenient for that reason. 20, so then I take that away. So I have 10 left. 20 doesn't go into 10. I need to, because there are many zeros here, right? I'll keep the decimal place. I have another 0 I can bring down whenever I need to. 20 goes into 100 relative to this position 5 times. 5 times 20 is my 100. Take it away. I have nothing left. No remainder. So the decimal version of 5/20ths is 0.25, 0.25. Now, yes, there are other ways to do this. You could look at an equivalent fraction and put it over a power of 10, but that's not always going to be so easy to do. In this case, we start with a nice simple example. Long division will always get me there. And then the benefit of having a decimal number instead of a fraction is when I do the arithmetic, it works in the same way with our methods that we've established before when we look at our number system. So it is much more convenient. But you lose some number sense when you start with this. You don't want to start with decimal numbers. Once you're comfortable with fractions, then we move on and see alternative representations and how it fits into the grand scheme of things. Let's try a couple more. 6/25. That means 6 goes in the house, 25 outside the house. I pick nice and easy denominators, see? Let me just check if there's any YouTube comments. I don't have it open. People don't comment often, but I have to be ready. All right, 6. 25 doesn't go into 6. 0. Keep my decimal point for positioning purposes. Then I need another 0, which is right there. 25 goes into 60 2 times. 2 times 25 is 50. I, of course, know relative to where I am, it's 50. I say 50, but it's not really 50. It's 50 tenths. Then I have 1 left. Well, really 10 relative to this. I need more zeros. Bring them down. I can look at 100. 25 goes into 100 4 times. 4 times 25 is 100. Relative to that position, I have nothing left. So 6/25 is 0.24. Again, you might say, oh, that was easy. Because we pick nice denominators to work with, it isn't terribly difficult, but we don't need it to be terribly difficult to demonstrate the method. Now I lost my last question. Where are you, last question? Let's do a 2b. Just take a super easy one. Because for little Timmy, he might have never seen 1/3, right? He saw it in his intuitive number sense building examples. Drawing a rectangle, representing a third, visualizing it, that's all good. But when it comes to decimal version, maybe he's never seen it before. So let's do it. So we put 1 in the house, 3 is the divisor, 3 goes into 1, no, never. 0 times. So I need another 0. Now I can look at 10, 3 goes into 10, 3 times. 3 times 3 is 9, of course, relative to where I am. So I have 1 left. Bring down another 0 because my remainder isn't 0 yet. 3 goes into 10, 3 times. 3 times 3 is 9. And then you're waiting for little Timmy to say, but wait, this is going to happen every single time. I'm never going to get out of this loop. Every time there's 1 left. Every time it's 3 times. I'll go on forever. Yes, you will. So you see here, there's a repeating section which means I'm never going to get a remainder of 0. This is going to go on forever. So there are decimal numbers that repeat forever, and we just put a little line over it. Some use a dot, I prefer a line, to indicate that the 3 is repeating forever. So that's the downside, unfortunately, of decimal numbers. They're not as clean as the fractions are. Some of them have decimals that continue forever. It literally never stops. And we will talk about rounding a little bit later. You have to round this number to sometimes work with it, and that could lose some accuracy. So that is the unfortunate downside to decimal numbers. There's a trade-off. I think they're still worth it, even though I have this property. So some fractions are what we call a terminating decimal number. Some are what we call a repeating decimal number. They're both fractions, but really it depends on what the numerator and denominator are. Could result in a terminating decimal, could result in a repeating decimal. But luckily we only get those two. Let's just do one more. This is number 3. 13 over 12. Now let's suppose we want to leave it like this. Instead of converting it to a mixed number first, maybe you don't even want to bother with that. It really doesn't matter what form the original fraction is in. I'm still going to have to divide by 12. 12 goes into 13 once. 1 times 12 is 12. Take it away, I have 1 left. I need some zeros here. So I have, relative to that position, 10. 12 goes into 10 0 times. I haven't done anything yet. Bring down another 0. Now I can look at it as 100. 12 goes into 100 8 times. 8 times 12 is 96. So then I have 4 left. It's not quite enough. Bring down another 0 for 40. 12 goes into 40. How many times? 3 times for 36. 36. And then I have 4 left. Still not 0. Bring down another 0. 40 again. 12 goes into 40 3 times. And then I start to see, ooh, wait a minute. There's my repetition. Every time I get the same remainder, I'm going to get stuck in a loop. Now you can verify a couple of times to be sure. Don't wait for just the first one. Be sure you get it repeatedly. Then you see, it's going to keep going like this forever. So what I actually have here is a repeating decimal number. Even though I might have a couple of 3's in my answer before I'm convinced that it is repeating, only put a line over the first one that is going to be repeated. Alrighty. Now, I don't know how familiar you are with these things. Could be very familiar, could be not at all. I'm going to do a number 4. Let's say 2 over 7. 2 is in the house. 7 is outside the house. Single digit, can't be that hard. 7 goes into 2 0 times. I need more zeros here. 7 goes into 20 2 times for 14. And then I have 6 left. 7 doesn't go into 6, bring down another 0. 7 goes into 60 8 times. 8 times 7 is 56. Of course, all relative to that position. Then I have a 4 left, which hasn't occurred yet. 7 goes into 40, goes into 4, 0 times, bring down a 0 to make it 40. 7 goes into 40, 5 times, 4, 35. Then I have 5 left, that hasn't happened yet. Bring down another 0. These arrows help me keep everything in line. It's very useful. 7 goes into 50, 7 times. That doesn't sound right. Do I do this right? Sure. I'm just thinking of something else. For 49, that leaves a 1. Bring down another 0 over there. 7 goes into 10 once. 1 times 7 is 7. For 3 hasn't happened yet either. Bring down another 0. 7 goes into 30 4 times. For 28, I'm running out of space here. 28 has left 2. It's not 0 yet. Bring down another 0 for 20. 7 goes into 20 2 times. 14. Take it away. 6 left. Ooh, and now I see this has happened over here. It has happened before. So finally, I'm repeating myself. And the next one's going to be an 8, 5, 7, 1, 4, and so on. So it does repeat, and a lot of it repeats, a large section. All of this repeats over and over and over and over forever. So a repeating decimal doesn't have to have just one digit repeating. It can have 2, 3, 4, many. This one has 6 of them repeating over and over and over and over and over. Still a repeating decimal. So it's really, in some cases, I have to be patient and wait, see. If it comes from a fraction, it's going to either terminate or repeat. And it's just a matter of how big is that repeating section. Could be longer than just a couple of digits. And I have to just be patient to wait for it. Assuming, of course, I've done all my little divisions correctly. I have to make sure that at every step I've done it right, so that a single digit here isn't unfortunately wrong. Then my pattern will get all messed up. So I have to be sure of all my multiplication tables, which is really what I'm using here. Okay, so that is one side of the coin. Which is from a fraction converted to its corresponding decimal representation. The other side is also there. If I'm given a decimal number, what is the fraction or mixed number that it comes from? Now, in some cases, that question is quite straightforward. Let's look at exercise 1413, and I'll just copy it down for us here. Number 1 is 0.378. In the case of a terminating decimal, this other direction, we've done the first one, right? This other direction is really not difficult, to the point where you almost don't have to say anything. If you understand what these decimal places mean, then the answer is quite straightforward. Let's suppose this way. 0.3 would be 3/10. because that's exactly what that decimal place means. 0.37 would mean 37 hundredths. So 0.378, as our example, is 378 over 1,000, because it stops in the thousands position. This is just a side note. So it's really as simple as just putting it over the appropriate power of 10. Let's look at number 2. It doesn't matter how late that is. That 8 is in the hundredths position. It's 8 hundredths. .95 is our next one. I don't care about the 5. I care about the decimal portion. I think almost it's better to do it this way, especially for what's coming up. This is just a 5, and 0.95 is 95 over 100. And I can then put it back into a mixed number, which is perhaps a more intuitive version. Or, of course, you could have gone 595 over 100 and have it as an improper fraction. Whatever makes you happy.
Please remember to click the like button if you enjoyed the video, and to subscribe if you want to be notified of more videos. Thank you.